Okay. So now we are going to be start with the kinematics, basically the mechanics of the part of that one. So one of the FRQ we are going to be discuss that. So first, I will request to you that this question, look into that question, pause the video, and try it from your side. First part of the question. So let me try it. So show that the working of the you're working on the each of the part of the question. Each part within the question may not have the equal weightage, so that they mention it. Okay. So we had to be take care of the this is the velocity time function. This is the velocity time function that they given it over there. So a cart is moving along a straight track, and the cart position x is initially zero, that they mentioned that velocity as the function of the time is described by this equation. So this is a quadratic expression that they given it, as they have already given the graph for that one. Even you can try it by plugging that one, you will get something like this. So where B and the C are the some positive constant, and the cart is initially at the rest, okay, at the t is equal to tr. So as you can see in the question also, so where the velocity at the time tr, the velocity function, yeah, basically the velocity is zero at that point, so it is zero. So as shown in the figure 1, so on the axis of the figure 2, sketch a graph of the cart acceleration as a function of the time for the time interval, as they shown it. Okay. So as we know that it is a velocity time function is given to us, to find out the acceleration, what you had to do is you had to be differentiate that, correct? So to find out the acceleration, so we had to be differentiate the velocity function with respect to the t, and the differentiation is come out to be 2b t minus c. So if you look at this carefully, this is some kind of the linear graph. You will get that something linear straight line graph. So you can compare, even this is the acceleration as a function of the time is come out to be 2bt minus c. If you compare that one on the y-axis, you can write it acceleration. This is the m, this is the capital X I'm writing over there, and minus c. This is the basically plus c. This is the intercept that we usually write it. This is the y-intercept. Basically here in this case, it is minus c, and the slope is the 2b that we have it. Of the graph that is come out to be, and on the y-axis and the x-axis. So you can sketch it easily. So let's practice that one. So they already given the graph. So here, so what are the things that we had to be take here is, okay, so before that, okay, so we had the acceleration in this straight line. So intercept is, y-intercept is minus c, so I can point it out at the minus c here. One more thing. So, okay, so when the time is zero, so it is the value is come out to be minus c on the graph. So, and t value is zero, that is going to give the acceleration is at that time t is equal to zero, that is minus c, that is the y-intercept that we have it. And to find out where acceleration is zero, to as I try to find it out where it is the time is zero, basically in this case on this x-intercept, I will try to find it out on the x-intercept. We had a t function. So to find out that acceleration is zero, so to 2bt minus c is equal to zero. So where the acceleration is zero, so to find out that time is come out to be, by the way, t is equal to c by 2b. So this is the time At this time, the acceleration is zero. I'm saying acceleration is zero. It is not necessary that always where the uh, where the velocity is zero, acceleration is zero. It usually you think it like this. When the acceleration is velocity is zero, acceleration, it's not necessary. So if you look at this carefully, if I give the simple example to you, when you throw the ball at a, it will stop momentarily for that point, but acceleration is still there, because acceleration is always to, if the ball is going up or the down, so acceleration is always negative, and that is z value is minus 9.8 meter per second scale. So in this case, even it is stopped at the maximum height, as we know that one, so acceleration is still there. So because acceleration is defined as a rate of change of velocity. A rate of change of velocity means final velocity, initial velocity, and the time taken to be there. So the point here is, it might be the final velocity zero. It might be the initial velocity zero. It doesn't mean that acceleration is zero at a moment when the velocity is zero. So that you have to take care. And even you can see the slope also. Even you can see the slope. There is a slope because uh, velocity time function, in the velocity time function, the slope will give you the idea of the acceleration. Here the slope is positive, here the slope at this one is negative. As you can see, what these are I'm drawing, these are the tangent line, by the way, tangent line. From the tangent line you can find out the slope of the curve. So but at this point, if you're going through the calculus, at this point the rate of change of velocity is zero at the maximum and minimum point. So if you look at this carefully, if I had to draw the tangent at this line, I'm going to draw like this. So if any line that is parallel to the x-axis that have the slope is zero, so zero, I mean to say that in this, the according to calculus, so basically the slope is zero. So at this point, so, and dv by dt is equal to zero. So to find out the maximum minimum point, we plug in that. So we must aware of that one. So at this point, the velocity is, I would say, rate of change of velocity is zero, not velocity is zero, velocity is zero at this point, at the time when the time is tr. So we are finding out this point, by the way, and this point where the velocity, rate of change of velocity is zero, where is acceleration is zero, I mean to say, because acceleration is dy by dt. This is acceleration. At this point, the slope is zero, slope is in the VT graph, that is acceleration. So this is the point basically. So the whole story is that it is somewhere here. So if you look at this carefully, the graph goes like this something. So let me make it first and let me point it out. So at the t is equal to c by 2b, the acceleration is zero. At this point, you want to find it out, you can find it out also. So this is the acceleration time graph that you will get that. So this is the y-intercept and the c. That is the first part is done. So now you can go through the B and the C part by yourself. Pause the video, try it from your side, and now let me move further. Okay, so derive the expression for the position of the XR that is negative, and furthest away from the initial point, initial position that they given it out there. Okay, so we know the again, so just think about this. We have the velocity time function. We have the velocity time function. The velocity time function. What that velocity time function is, please? That is vt square minus ct. So we had the velocity time function. So how to find out the position according to the calculus? So this can be easily be done. So even you can write like this: dv So I had to write like this. To find out the position, we had to be integrate. So how much the position it is? I'm going to integrate the velocity time function to get the position. So, okay, so let's plug in that then bt square minus ct and dt. So then b is a constant, t we increase the power by 1, divide with the same power, minus c increase the power by 1 because it is 1 here. Now I'm going to increase by, make it 2 divided with the 2 and some constant. So that is the x, that is the position, basically position time graph. But right now, as per the question, they have mentioned the initial position is 0. Initial position is 0. When the time is 0, it means to say that. So this becomes 0, this becomes 0, and C. Because it come out to be C, so the initial position is already, they have given that it is 0 when the time is 0. So C value is come out to be 0. So the position time graph is just come out to be bt 3 minus t square by 2, and that is the position time graph. Now, so okay, so you get the position relationship between the position and the time. Now the challenge is for us is, as per the question they are mentioning that one, so negative, it should be negative. Right now I haven't put any kind of the condition to make sure it is negative positive, and further away from the initial position. So if you look at this carefully, the velocity time function, if I go to over there, so as we know that area under the velocity time graph will give you the displacement. So area under the time axis and the velocity function, this area, and even this area, even this area. So basically, so this area is this is negative. This is because this displacement is negative the x-axis or the time axis right now. So this is the negative displacement. And this is the positive displacement, by the way, if I had to mention that one. But they are expecting us to find out negative. What that negative displacement, if I had to just try to explain to you, is it just means that the you started from the mean position and the person has moved on the negatives. It keep on moving, keep on moving, keep on moving. Eventually its speed is changing as per the graph that they given, but at the tr, it is the, when the time is tr, basically it is on the maximum negative side. So that is only that we had to find it out at the tr time, it is in the maximum. So right now we had to first find out the what is the uh, tr, to find out the tr where the velocity function is 0. So let's to first we what we can do is to find out the tr value where the, because as we get the time, so I can plug in the time in the position time 1. So I can plug in the tr value here in the position 1 and I will get that. So basically the point is the velocity function, we already have it. So this is the velocity function. To find out the tr, what I can do is, so where the velocity function is 0 at the tr, when the velocity is 0, it means it is the furthest negative point displacement. So, and this is vt square minus ct, that is 0. And from there you can find out the t, as a t you can take it common. bt minus t is 1 t value is you will get 0 when the time is 0, displacement is 0, as we know that one. So, and the next one is t, the this expression is 0. Basically, when the two things are 0, it means this have to be 0. The product of the two values are 0. It means this have to be 0, this have to be 0. Then either means that, oh, this have to be 0 or y have to be 0 then only. So we just put the factors equal to the 0. So we get the b value. B value is c by, sorry, t value is c by b. So tr, I would say. So I had to mention tr, sorry. So I haven't taken care of that. Just plug in the tr because we are at the tr, we are trying to do that. At the tr, the position velocity is 0 and it's the furthest point. So it is c. Tr value is c by b and just plug in into that. So when the t is equal to tr, b, tr value we already know that how much we calculate c by b. To be okay, so this is the constant that is come out to be. You can make the same denominator, so it is 2 minus c cube by 6 b square. So this is the basically the furthest negative displacement. You should get the negative one only. So this is the answer for the negative displacement that you will get that. So this is the second part or the B part of that one. So let's move to the C part. So derive the expression for the velocity Vt that the cart has when it passes through the position x is equal to 0. Okay, at the later time. So basically, they are expecting us to find out the drive the expression. So we had to drive the expression where the velocity for the velocity that the cart has been passed through the position of. Okay. Now, if you look at this carefully, as we discussed in the last part of the question, so this is at the TR. This is further apart, means negative displacement, and that is come out to be, by the way, minus c cube by 6b square, if I'm not wrong, just verify. So basically the point is this is the further part. They are expecting that when it is come back to the original position, means that now as it will after tr, as it start moving, so this is the positive displacement, as I mentioned it before also. So this is the positive displacement. So this is negative displacement. This is the below one is negative displacement. This is positive displacement. So after somewhere here, so at that time the position becomes 0 because this is negative, this is have to be positive. So eventually it come to the original position. So we had to be find out the time expression where the position becomes 0. So basically where the position is. So you already had the position time function. So you have this is the, so I'm doing the C part of that one. For that one, I'm writing this position function. So this is xt. So this is bt cube divided with the 3. Sorry. This is 2. This is 2 here. Three by 2 C 3 by 2 C by. So this is the basically the time that is come out to be where the position is 0 basically, because eventually it goes and come back where the position is. We have the time 3 by 2 c by b. I'm going to plug in the velocity function because that is only that they're expecting us. Drive the relationship at the velocity. So the velocity function that we have it is bt square minus ct. So this is the velocity function that I have it. And then I'm going to plug in that t value that we calculated where the position is 0. That is 3 by 2. So 1b, I'm just cancelling out that one. Eighteen minus 12. So basically, this is the expression that is come out to be. Please verify all the calculation from your side. So, okay, so this is the expression, by the way. So you can simplify 3 by 4, and that is your final answer. Thank you. Have a good day.